going to go down to, these are the work we'll do. We'll also do some HSC question today. So velocity as a function of time, we've been doing that. So let's review this concept again. We're going to find acceleration and displacement given v equals to 2t squared over 3. And it's given that when t is 0, x is negative 3. So what we do is, if we're going to find acceleration, you just have to differentiate. It's very easy. And if you differentiate that, you get 4t over 3. Right, pretty easy when you get acceleration. And how do I get displacement? Also pretty easy. You just write dv dt, dx dt is v. V equal to dx dt. And to find x, you just have integrate in respect to time. 2t squared on 3 dt, which gives you 2t cubed over 9 plus c. And when you find c, we use the fact when t is 0, x is negative 3. So you get negative 3 equal to 0 plus c. So c can be found. Therefore, x equal to 2t cubed over 9 minus 3, which is your final answer here. This is acceleration. Alright, so this is something we've learned in advanced maths, 2-unit maths, which is just very easy. So if you start with v to get x, you integrate, and then to get acceleration, you differentiate. Okay, so there's a simple connection between all three quantities. Okay, so today we're going to do something a little different. Once you're ready, go to the next page. Okay, let's go through this. Okay, let's move on. So it's pretty easy. So next page, we're now going to look at velocity as a function of x, displacement, instead of t. So see, in this example, we got v in terms of x instead of time. And the question is, why do we do this? Well, in many physical situations, the acceleration or velocity of the particle is more naturally understood as a function of where it is, the displacement, rather than how long it has been traveling. For example, the acceleration of a body being drawn towards a magnet depends on how far it is from the magnet. In such situation, the function must be integrated in respect to x rather than t, because x is the variable in the function. So as you can see, it's sometimes better to express velocity in terms of x, because it's easier to understand in terms of where it is from the position rather than how far it has been traveling. Okay, so what do we do in this case? So if I want to find displacement in terms of t given v in terms of x, what we need to do, I'll write that as dx over dt like before. That's your first step. But the question is, unlike the one we did before we did dx dt equal to 2t squared over 3, I could just go dt, isn't it? That's no problem. But this one, if I do this, that's a problem. I can't do dt. I can't integrate it because this is x, this is t. So you can do that if it's in terms of t, but not in terms of x. So what we do is, how do we overcome this problem, is to reciprocal both sides. If we're reciprocal, then we can integrate in respect to x rather than t. So we're going to, the key point is to reciprocal. So when you're reciprocal, you end up getting dt over dx equal to 3 over 2x squared. And then after that, you can write t equal to the integral 3 over 2x squared dx. Now we can integrate because it's now dx in terms of dx. So that's the first thing you just need, that's the key point you need to know. When v is in terms of x, you reciprocal to find t in terms of x first before you make x in terms of t. And now it just becomes an integral you know how to do. So you have to write t equal, writing in index form, x power negative 2 dx, like that. And then we integrate. So we get 3 over 2 x power negative 1 over negative 1 plus c. And then we have to find c. So we get negative 3 over 2x plus c. This is t still. Okay? And once you do that, use the fact that when t is 1, x is negative 1.5. Substitute t equal to 1 into t, substitute negative 1.5 into x, then you can find c. Alright, okay, let's do that. So, negative 3 over negative 2 times that plus c. 2 times negative 1.5 is negative 3, so they cancel. You get 1, isn't it? So you get 1, so c is 0. C is 0, and after that, you update your formula, c is 0. So therefore, t equals to 2 over, no, 3 over negative 2x, and c is 0. And to make x the subject, you write x equal to negative 3 over 2t. That's your function displacement in terms of time. Alright, so note the procedure. So the only thing you have to do first is to reciprocal before you integrate. And the result you will get is t in terms of x before you making x the subject. Okay. Alright, good. So it's pretty straightforward once you know this. And now once we got x in terms of t, we can now find v in terms of t. To find v in terms of t, there are two ways. So you either differentiate x to get v, or you can substitute that into this. Okay, let's do it both ways. So let's write it in method 1. Method 1, you get x equal to minus 3 to t to the power negative 1. So to find v, you just have to differentiate. So you get 3 over 2 t to the power negative 2. Okay? Which becomes v equal to 3 over 2t squared. Or you can do method 2. You don't have to differentiate because we already know that v equal to 2x squared, which I think may be a bit harder this way. Alright, and then what you do is you substitute that into x. So therefore you can get 2 over 3 times by negative 3 over 2t squared. And then if you square it, you get 2 over 3 times 9 over 4t squared. The 9 cancel, you get 3, 2 cancel, you get 2, which is the same thing, 3 over 2t squared. Okay? So they are both the same. Alright, good. Any questions? So it's pretty straightforward. And once we get that, we can answer the last question, is to find the limiting value. And how do we find the limiting value? So displacement, let's write x in terms of t. X is equal to negative 3 over 2t. And then v equals to 3 over 2t squared. In both cases, when t goes to infinity, because t is in the denominator, they must approach 0. But they both approach 0. So you can say both x and v approach 0 as t goes to infinity. Right, good, done. Alright, so now we'll look at a very typical example. Of course, that can be applied to any function that you learn how to integrate. So this is velocity in terms of x. What do we do if it's acceleration in terms of x? We'll go through that as well. So, okay, so take a minute to write it down. Okay, all done. Alright, good. Okay, so we do exercise on this. Okay, next bit. Acceleration in terms of x. Could we do the same method? Now, acceleration is dv over dt. Now, if we integrate v, actually, to find, so that's acceleration. To find v, we can't do that, isn't it? Because that's x, that's t. So we can't do this. Now, what if I flip it? Flipping what? dt over dv equal to 1 over 3 minus 2x. Well, it still doesn't work because t equal to this. They are different. So the flipping method doesn't work. The integrating directly doesn't work because like none of this v and t doesn't have x in it because that's x. You need to have at least one of them is x. There's no x there. So what do? We need to have a new formula. So we need to have a new formula for acceleration. So acceleration is dv over dt. The new formula is this. I don't think it's on the formula sheet. Let's double check. Maybe it is. No, oh, it is. They actually give you a proof. Used to be not examinable. Alright, that's good. It's actually on the formula sheet. On formula sheet, on reference sheet, which is the good news. Reference sheet used to be not given. Okay, so it's on the reference sheet. They gave it all to you. So on the reference sheet, it says d2x over dt squared equal to dv dt equal to v dv dx equal to d over dx half v squared. Half v squared. Okay, so this is on the reference sheet. So, but we still need to know how to prove it because I think you need to know how to prove this result. And the proof is examinable. Okay, so we need to see why acceleration is d over dx half v squared. Okay, so let's go. Oh, they actually has quite a few information. We got this result. We got that. Okay, I should look at it more closely. Okay, let's look at the proof. The proof is not very difficult, so let's see how we can prove it. So we start from the right-hand side. Let's show why this is half v squared. Why is differentiate half v squared gives you acceleration? Okay, so what you do is this. To differentiate half v squared, you must have to differentiate in respect to v first. So let's write this in different color. Half v squared times dx, and you just have to insert a dv here, dv there. That's your first step. So you have to in order to differentiate half v squared, you have to differentiate in respect to v. Okay? And if you differentiate half v squared, you will get half times 2v. Right? Derivative of half v squared is 2v times dv over dx. And the 2 get cancelled. So you end up getting v dv dx, which is on the formula sheet, which is over here, v over v dv dx. That's where that come from. And then y is equal to acceleration. We have to do one step further. So they give you the formula, but not the actual proof. V is dx over dt, right? Actually, I'll write it in green pen. So this v is dx over dt, dv over dx. And why do I do this? Because the dx gets cancelled. You end up getting dv over dt. And what's dv over dt? It is acceleration, which is the x double dot, which is the left-hand side. Alright, so the proof is examinable, and it's not very long, but it can be tricky because you need to remember what to do in the first step, so you have to remember to do this. That's not obvious, isn't it? And then you have to remember to write v in terms of dx dt, which is not obvious. But these are the critical steps, and if you can remember these 2 steps, you're able to do the proof. Okay? Again, remember, it's examinable. Now, the next question is, how do we use this result? We're going to use this result to do a question, and then we'll do a HSC question. Okay, I'm actually write this down, the proof. Alright, okay, so let's move on. Okay, next page. Okay, which is this example again, acceleration is 3 minus 2x. How do we find velocity from there? Let's do this. Okay, so we got x double dot is this. So what you do is replace the x double dot by the over dx half v squared. Like that. So you get 3 minus 2x. So your first step is to change the acceleration, that formula we just learned, d over dx half v squared. And why do we do this? Because to remove the d over dx, we can integrate in respect to x. And when we integrate in respect to x, my result is half v squared. Not v, it's half v squared when we integrate the acceleration in respect to x. Okay, and then we continue. Half v squared equals to 3x minus x squared plus c, using the formula we learned about integration. And then we use the information when v is 2, x is 1. So when v is 2, x is 1. Like that. And then you're going to work out, so half times 2 squared equal to 3 times 1, and then 1 squared plus c. So now you have to work out what c is. Half of 2 squared is 4, which is 2. 2. So c is 0. And you can update your formula. So half v squared equal to 3x minus x squared, c is 0, times everything by 2, give you v squared in terms of x. So it's quite convenient. Okay, so I just show you again. Now we still have to find v because that's v squared. The question is find v in terms of x, so you have to square root it. So square root can be a bit tricky because remember, when you square root, it's plus or minus. And the question is, which one do I use? Well, which one you use depends on your initial condition. Now we'll write this thing over here. That tells you when x is 1, v is positive. Because v is positive, therefore we must take the positive square root. So you give a reason v is positive when x equal to 1. So that's how we know. So look at this condition. What else are there? We'll do the next one. We'll do the same thing again for the next one. V is negative 2. So do the same thing again. Start with x double dot. I think you get the same result. Very similar. Alright, try this one. And do this whole thing again. Alright, we'll continue. So, okay, so it's the same thing, d over dx, half v squared equal to 3 minus 2x. And you get the same result, which is half v squared equal to 3 minus 2x. Plus c, and then you're going to find out what c is when v is negative 2, x is 1. I think you still get c equal to 0. Okay? C is 0. So you get the formula v squared equal to, actually that should be x squared here. Okay, so you're going to get 6x minus x2 x squared. Is that what I wrote before? Yeah, 6x minus 2x squared. Okay, and then you're going to square root like before, plus and minus. But because when x equal to 1, v is negative 2, negative. So you take the negative square root. So v equal to the negative of that. Because when v is negative, when x is equal to 1. Okay, so see the difference in the condition, which lead to a slightly different formula. So positive if your velocity is positive to begin with, or negative if your velocity is negative. Okay, so once you know this, we can look at this motion a bit further, and we can understand that more deeply. Okay, so after you're done, we're going to look at the restriction on x. Now, they both have the same equation, except the only difference that one has a minus. We're going to look at the restriction on x. Now, what's the restriction? If it's inside the square root, that means this has to be greater than 0 or equal to 0. So you have to solve this. So to get the restriction on x, solve this inequality. See if you remember how to solve it. Okay, solve this. Now, how do we solve this? It is a quadratic inequality, so to solve this, we first solve is solve this equation, which means 2x 3 minus x. Therefore, x is 0 and 3. 0 and 3. And then we get 0 and 3. This is a concave down parabola. And then you get, this is positive. Positive, so therefore x is between 0 and 3. So what does that tell you about the motion? That the particle only moves between 0 and 3. It cannot move more than 3 or less than 0. Okay, so that tells you that the particle can only move in this domain for x displacement. It cannot move to a different position other than the position between 0 and 3. That will be useful for the next part. Okay, now we're going to describe the motion. So what's really happening? So let's look at the motion. So we got the equation for x double dot equal to 3 minus 2x. Let's look at the acceleration. Acceleration. And what we're going to do is, let's work out the position at the extreme. So you can think of this at the extreme of the motion. So at x equal to 0, at x equal to 3. Okay. Now what's the acceleration when x equal to 0? You get 3. And what's the acceleration when x equal to 3? Substitute 3 in there. You get 3 minus 2 times 3, you get negative 3. Like that. Now, what's the velocity? Now, they both have the same equation. One of them is positive. The other one is negative. Let's see the meaning of this. Why do we have two different equations for velocity, but with the same acceleration? Let's see what that means in terms of the motion. Now, in both cases, when you substitute x equal to 0, what's the velocity? If you substitute x equal to 0, you get 0. Whereas when you substitute x equal to 3, what would you get? In both cases, you always get 0 as well. So what that tells you is stop at the end point, isn't it? It stopped. So in here, it stopped. You stopped at 0 and you stopped at 3, which is one way to understand why doesn't it move beyond 0 and 3? Because that's where they stop. They don't go beyond 0. That's when they reverse the direction. So let's look at it more, even at a deeper level. So when you stop at the origin, what's happening to the acceleration? There's 3. So what does the acceleration do? It increases the velocity. So it starts to move right, right? And then as you move right, we'll use this formula for velocity. So it's moving right until you stop at 3 again. And what happened when you stopped? The acceleration is negative. So what happened with negative acceleration? Velocity will decrease, hence the velocity, the particle will start to go back with this equation. Now you understand why there's two equations. One equation for moving forward, one equation for moving backwards. That's why there's two. And then when you move backward, by the time you move here, stop again, the acceleration is positive, you start to move forward again and go backwards and forward. And this motion reminds you of simple harmonic motion. Yeah. Or with the tangent, if you graph this against so if you graph, you mean graph acceleration or you mean graph the velocity? So if you graph velocity against x, I think the graph will look like this. So v against x. So at the origin, the velocity is 0, as we expected. Well, if you look at the tangent, it's actually dv over dx. And the tangent doesn't correspond to acceleration because acceleration is d over dx half v squared. So this is not really representing, well, you will be undefined if you differentiate it. Differentiate dv dx, but dv dx doesn't have meaning. It's d over dx half v squared. Yeah, okay. All right, so we look at the motion in terms of acceleration and velocity. We see that this is representative of the simple harmonic motion, moves forward and moves backwards. And you will see another reason why it's simple harmonic, because it can be written in this form, -2 x minus 3 over 2, which is the form for simple harmonic motion, with the center at 1.5. Now let's describe this again. So let's go through this. Oops. Okay, so the particle starts at 1, traveling to the right at v equal to 2. So as we see here, that's when x is 1, v equal to 2. So it's moving to the right at 2 meters per second. Actually, I should change that to at 2 meters per second. And then it stops at x equal to 3. It stopped there. And the acceleration becomes -3 meters per second square. This indicates that the velocity will decrease. Decrease from 0. Okay, it will decrease. Now the particle will move, because the velocity will decrease, the particle will move left. Right? So when the velocity decreases from 0, the velocity becomes negative, which means it will start to move left from here, speeding towards the origin. When it reaches the origin, it stops again. It stops, and the acceleration is positive. And because the acceleration is positive, this indicates the velocity will increase from 0. And if it increases 0, the particle will now move right, speeding towards x equal to 3 again. So it goes backwards and forwards. And when it reaches 3, velocity will stop, acceleration will be negative, it starts to move left. So go right, left, right, left. This is an example of simple harmonic motion as it moves between two fixed points periodically. Right, we'll study this example more carefully in the next exercise, but today we'll just look at this in general terms. So let's do a summary. This example took a long time. But anyway, but now you have a better understanding of this concept. Let's do a summary of all the things we've learned today. Let's look at this one more time. So, it's possible to get v in terms of t. So to get v in terms of t, you just have to differentiate dv dt to get acceleration. Simple. And when you get x, you integrate v dt, which is equal to integral 3t squared dt, which is t cubed plus c. Okay, so we've got x in terms of t, acceleration in terms of t. So that's when v is in terms of t. And then the other bit, what if it's v in terms of x? You do something a bit different. So to get v in terms of x, if you want to find, why did my x get disappeared? But anyway, oh yeah, because you don't get x straight away. So if you want to find acceleration, to find acceleration, you not only have to differentiate, you have to find v squared first, which is 9x to the power 4. And then you have to go half v squared. Half v squared is 9 over 2x to the power 4 before differentiating half v squared, giving you the acceleration. Okay, so note the extra step involved when we have to find acceleration when v is in terms of x. Note the extra step needed. Whereas tuner level, easy, just differentiate in respect to t. That's your acceleration. Acceleration, velocity in terms of x, you need these steps. So that will be differentiating this becomes 9 over 2 times 4 x power 3, which is 18 x power of 3. That's your formula for acceleration. So note the differences between the extension 1 component and the tuner when things are in terms of t and when things are in terms of x. Of course, in your tuner exam, you won't get expression in terms of x. It's always in terms of t. It will just be a simple process. Okay? And then let's look at again what happens if we want to find displacement. Yep. So you differentiate half. Oh, v. Sorry. Oops. Yeah. You're right. Differentiate half v squared. Yeah. So differentiate half v squared, you get 18x cubed. Okay, good. All right, and if you want to find displacement, you start off with dx over dt equal to 3x squared. Again, you can't integrate straight away like you did in advance. You have to reciprocal first. Reciprocal this, so you have to go dt over dx equal to 1 over 3 x power negative 2 before integrating, which you will get t in terms of x. So you get 1/3 x power negative 1 over negative 1 plus c. I won't be finding c. I didn't give you any initial condition, but you know how it works by looking at the condition. Right, so note the differences. Note the differences between them. Okay, tuner is very straightforward. Extension 1, you have to do a bit more step. So look at it more detail to remind you how to do this. Okay. Okay, so hopefully all done now. What happens if we got acceleration in terms of x? See, this is velocity in terms of t, velocity in terms of x, acceleration in terms of x. Let's do that. So again, we'll look at the tuner version. To get velocity, you just have to integrate acceleration. Very straightforward. So you don't have to think much, which is 2t power 4 plus c. But acceleration in terms of x requires a little bit more effort. You have to remember to use d over dx half v squared, which is now available on your reference sheet. So you can just write this down from your reference sheet. So you get half v squared equal to 2x power 4, like before, but it's plus c. So you get different subject. This is half v squared, this is just v. Okay? And then you just have to find c from the initial condition. And then we'll do an HSC question after this. Yep. Oh yeah, you're right. Yeah, sorry. Okay, yes. So it'll be 6 over 4. Then that will be wrong there. Okay, so it'll be 6 over 4. And you end up getting half v squared, 3 over 2 x power 4 plus c. This will be v equal to 3 over 2 t to the power 4 over 2. Okay, so note the differences and similarity between them. All right, so all done? Okay, let's move on. Next page, HSC questions. Alright, so that's one HSC question asked in 2007. Particle moving in a straight line with acceleration given by that. It is initially at the origin, traveling with velocity 1. We first have to show the acceleration. Velocity is equal to e to the power negative x. So let's write down the result. d over dx half v squared equal to negative e to the power negative 2x. When we integrate, we get half e to the power negative 2x plus c. And we use the condition when x is 0, v equal to 1. So you substitute 1 into v, 0 into x. And you get half times v1 squared, half e to the power of 0, which I have to write a bit closer, plus c. And I think c gets cancelled. So you end up getting half equal to half plus c, so c equal to 0. I think the one we did before are all 0. It can be not 0. Yeah. It's just the question made in such a way that it's 0, so that's easier to do. Okay. All right. So we continue. So we get half v squared equals to half e to the power negative 2x. And then we'll multiply both sides by 2. So we get v squared equal to e to the power negative 2x. Now you have to find v in terms of x, so you have to square root it. V equal to square root of e to the power negative 2x plus or minus. And when you square root, it's same as taking it to the power of half. Right? Half times negative 2 is negative 1 plus or minus. Right? And the question, which one do we take? But we note the fact when x is 0, v is 1, which is positive. So we take the positive square root. V is positive. So we say, therefore, v equal to e to the power negative x, which is what you have to prove. Okay, that's for part 1. Okay, good. Once we do this, we can then do the second part. We have to find x in terms of t. So you have to use this answer here. So if you didn't get this answer at the beginning, just use it from the question. Write x dot equal to e to the power negative x. And to find x in terms of t, we have to write x dot as dx over dt. And remember to reciprocal. So for reciprocal, that's an x. Okay, with reciprocal, we get dt over dx, which is 1 over e to the power negative x. So you have to reciprocal first before we integrate. Okay, we integrate. And then we're going to write that in simplify, so you can write that as e to the power positive x, right? And that's easier to integrate. So you get e to the power x plus c. Like that. Now, after we do this, we use the fact that when t equal to 0, x equal to 0. And then you can use it to find c. So e to the power 0 is 1. Therefore, c is negative 1. Like that. So now update your formula. I think I left 2 less space. Should be more space. Okay, so we get t equal to e to the power x minus 1. Make that the subject, e to the power x. And then you get log base e, t plus 1 equal to x, as we expect. Yep. Okay, good. All right, any question? And then we'll do the next question. Next question is 3 marks from 2017. That's last year's paper. Let's see how that works. So we're given t in terms of x. They want to find acceleration. So what you do is, to find acceleration, one way to do that is, let's write method 1. One way to do that is to find x in terms of t. So you can write e to the power negative 2x equal to 4 minus t, or negative 2x equal to log 4 minus t. And then what you do is, you just have to integrate both. So you integrate to right, so you get x dot and then v dot. And then after you got x dot, you write x double dot. That's one way, but then you have to write that in terms of x. You have to substitute x back into the formula, which can be a bit challenging. Actually, we could finish that off. So, so you got, what's v dot? That will be, let's do that. So we get half, so you get negative half times negative 1 over 4 minus t, and you will get the negative cancel, you get 1 over 2, 4 minus t, right? And then you have to write that in index form, 4 minus t to the power negative 1, up to mark the row. Oops, okay. I got it. Thank you. I will do that right now. Row is here. Dora. All right, done. Okay, good. All right, so we're going to find x double dot, which is half times negative 4 minus t to the power negative 2 times negative 1, which will cancel 1 over 2, 4 minus t squared. And you have to write that in terms of x. What would that be in terms of x? Well, that's 4 minus t, isn't it? 4 minus t is over here. E to the power negative 2x. So that's e to the power negative 2x. You get 1 over 2, but you have to square it, which will get 1 over 2 e to the power negative 4x, which is equal to half e to the power of 4x. Right, that's acceleration. And then I'll show you a faster way using extension 1 method. So you have to substitute that in here. Okay. All right, now I'm going to show you method 2, which is much quicker, method 2. So how does method 2 work? We're going to do, so instead of making x the subject, we're going to differentiate in respect to x first. We get dt over dx 2 e to the power of negative 2x. Right? Now, why do I do this? Because if you reciprocal that, I get v. Right? Which you get v equal to half e to the power of positive 2x. And now acceleration is just a couple of steps away. So you get v squared equal to a quarter e to the power of 4x. Half v squared equal to 1 over 8 e to the power of 4x. And what's acceleration? D over dx half v squared. So you get 1 over 8 times 4 e to the power of 4x. which is half e to the power 4x, as expected. Okay, good. So think about this. There's some good exam type question in the HSC. Make sure you practice the Success 1 book and do exercise 3E today.